In this video, we will diagnose and discuss a Code 54 error on this 1989 Iroc Camaro with the 350 TPI engine. The Code 54 set the check engine light on. In addition, another symptom related to this fault was extended crank times before the engine would light off. This was particularly evident on a cold start and was less obvious when the engine was warmed up.
All right. So key on, no flashy. The ALDL droid is connected. And give her a start. So we have a code. Not sure what that is yet. This check engine light is on. Why is it on though? Okay, we can go to real-time data. That will give us the error codes, whatever they are. This is something that's come up twice now. It's error 54, low pump voltage. Low pump voltage. And I didn't hear the fuel pump kick on. I think what this is telling me is that the first time I didn't hear the fuel pump prime. I think the fuel pump relay might be sticky or going bad. I think what pretty sure that's what that's indicating. I think that, in fact, if I stop the engine and start this back up, that code will go away. But I think it is indicating that we may have a flaky fuel pump relay, maybe going bad. This is interesting. The fuel pump voltage is, half a volt lower than what it is at the ignition switch, which is kind of strange. Still open loop. Okay. Alright, let's see. Let's go away. Yeah. So it's gone away. Something to investigate further is that are we having a problem with a fuel pump? So it's currently a half a volt difference. I'm not sure if that's normal. I seem to recall that it isn't normal. Okay, so we're back at it with a little more testing and troubleshooting. I did find an error that I had made in the wiring again. This is the second error I found, so again, I reiterate how important it is to recheck all your pinning. What had happened was I was having errors where I was getting a low fuel pump voltage code on the ALDL scanner here, and that was happening primarily when I'd first start the car up when it was cold. You'd have a long crank, so you'd crank it and crank it and crank it and crank it, and then it would light off. Much longer than what you'd normally just bump the starter, and these things normally should just light off. That combined with the code 50, or I think it was 54, I can't remember. Anyways, it was a code, it was low fuel pump voltage. That indicated to me that, and the fact that when I turn the key on, initially when you turn the key on, it should prime, and you should hear the fuel pump prime. It runs for about 5 seconds. That was not happening. But it was working before I did this computer change, so that sort of prompted me to think, okay, this has to be a pinning problem. So two things here. So anyways, it was supposed to be in, I want to say the fuel pump, which is fuel pump wire, is a green and white wire, and it's supposed to be pinned to A11, and I found that I had put it into B11, which is directly underneath, so I just had the plug was flipped over. Now, you know, and that particular port, or that plug on the computer, is for vehicle speed sensor output, which I believe in this application is not being used. So who knows what weirdness was going on because of that. Also, I think possibly the lower, because again, on this scan, on the log, you could clearly see that the fuel pump voltage was about a half a volt lower than the ignition voltage, or the rest of the system voltage. Now that could be indicative of that because so what happens with these cars, it's a little difficult to, well, I'll just do a quick explanation. Basically, these cars have two circuits, sort of a redundant circuit that powers the fuel pump. And that is to say that there is the primary circuit goes through a relay. So from the computer, that green and white wire goes to a relay, triggers the relay, which turns on the pump, and it turns it on when you want to prime the engine, or initially when you turn the key on, you prime the pump, and it also will turn it on when the engine is running to obviously keep pressure going and keep the fuel pumping to the engine. That's the primary circuit. When they had put in a sort of a redundant parallel circuit into these cars, so that if that fuel pump relay fails, it will then revert to an oil pressure switch. So in parallel, there's an oil pressure switch, and when you when that switch sees pressure, it closes, and then you'll get an alternate source of power to the circuit, to the pump circuit, through that switch. Which is why that explains why when you when that relay was not working, it took a long cranking time for the engine to light off, because it would not light off until you turn the engine over, it build up oil pressure, the oil pressure would close the switch, and that would then allow the current to flow through the switch, turning on the pump, and then the pump would have to prime, and then eventually the engine would light off. It would cause, basically you would need like 20 seconds of cranking before the engine would start initially. Now after that, once everything was warmed and the system was primed, and the oil system was primed, and the fuel was primed, it would then start pretty quickly. A quick bump of the key and it would light off. But for the initial start every morning, I was having long crank times, and that is indicative of a failed relay circuit, in that it's running on the oil pressure switch. So anyways, that's now corrected. I repinned it, and we'll see here. I don't know if you can hear it. Hear that buzzing noise? That's the fuel pump. So the fuel pump does prime whenever you turn the key on now, So now we're going to start it and we're going to run it.
So what we can see here now is that the fuel pump voltage is 14.3 volts, up from 13.9 where it was before, and it's only about zero point 0.3 volts lower than the battery voltage. So now if we take a look at the schematic, what we can attribute that difference in voltage to is, as you can see, the voltage is now passing, it comes from the battery and it splits. One side goes to the relay, one side goes to the oil pressure switch. The lower voltage when it was passing exclusively through the oil pressure switch could just be because that switch doesn't pass as much current, or it could be dirty or whatever. But whatever the reasoning for that is, it is a very good indicator that you have a problem where your relay is not closing. Because the primary path of current is through that fuel pump relay, and when it's closed you'll get a higher voltage on the sense line, the gray sense line, and the reading in the ALDL stream will be higher when it's going through the fuel pump relay rather than when it's going exclusively through the oil pressure switch. So that will really tell you that you've got a problem there. So what we're looking at here is ALDL Droid's live stream. This is the live data, and as you can see under error 54, it says OK, which is to say that the code 54 error is now cleared since we restored the function of that fuel pump relay. 90% of the time when you get a code 54, it's going to be that fuel pump relay. In my case, it happened to be that I had pinned the fuel pump relay line in the wrong position on the computer, but that obviously is not going to be the case most of the time. Most of the time it will be due to a fuel pump relay. Now, in case you're wondering where the fuel pump relay actually is located on these cars, on this 1989 Iroc Camaro, it is on the driver's side of the cowl, right near the power brake booster. It's the first relay on the left in that series of 3, and it is the rectangular relay. That's not always the case on all of these F bodies. I can only attest to the fact that on the 89 it's that rectangular relay. I know on my old 91 it was more like the sort of oval shaped relays to the right, but on this 89 it's the rectangular. Okay, and with that, that brings us to the end of this overview of a code 54 fault, which was also accompanied by a long engine crank time. If you enjoy these videos or find them in any way useful or valuable to you, please like and subscribe.